Hello all, in this particular tutorial we will learn about Oracle RAC concepts and theory. This particular tutorial will help you to prepare for your interview questions because we are going to cover the concept of how the RAC works and what are the terminology, and once you go through this particular slide then you will be able to understand the RAC working knowledge of RAC. You will have a theoretical knowledge of RAC and all the components that makes up the RAC and how RAC functions, which will allow you to answer your interview. Now this is not a Q&A where I am not going to ask a question and give you the answer. Basically the theory covered here will prepare you for your RAC interview. Now before you start watching this particular tutorial, I would like to make one point very clear. There is no practical session. This is completely theory. I have created videos on how to set up RAC. There will be another video which will talk about the RAC commands, and in that particular video you will see how the multiple RAC commands and how you can perform multiple RAC functions. However, this is a complete theory. Now, before we start understanding the RAC, I would like to explain what is the clustering concept. Basically, clustering is a concept where a standalone server grouped together with additional software function as one unit. Basically, it is nothing but multiple servers, and those multiple servers you install some kind of software on it and then you create a cluster. The clustering is not specific to Oracle. Clustering is a term where you can have clustering in Windows, you can have clustering in Red Hat Linux, you can have clustering in Solaris, you can have multiple different types of clusters. And the cluster concept of cluster means you actually combine multiple servers together to form a single unit, a collective unit. So Oracle Clusterware is a cluster software that provides high availability for Oracle databases. Oracle Clusterware enables servers to communicate with each other. So the servers which are part of the cluster communicate with each other so that they appear as a collective unit. In this way, the separate server appear as if they are one system to application and end user. So it looks like from the end user, it looks like it is a one application. It is not. But however, behind the scene, there are multiple servers which forms the cluster. A cluster consists of one or more servers. These servers are called as cluster member or node. Sometimes they are called as a cluster member or sometimes they are called as a cluster node. Oracle Clusterware was first released with Oracle Database 10G R1. So this is something that you would like to know. It was first released with 10G R1. What are the benefits of cluster? The benefits of cluster are multiple, such as high availability of Oracle databases. And when I say high availability, if one of the, let's say you have 3 or 4 servers and one of the server goes down, your Oracle database will still be up and running. Those 3 other servers will continue to work and the application will continue to run. You have the ability to failover. So you can say that you want to failover the application from one server to another. You have scalability of applications because you can add multiple nodes to the cluster. If tomorrow the application wants to scale higher, then you can add multiple nodes to the cluster. You can add nodes to the cluster. Since you have multiple nodes serving the same database, you have increased throughput. You can increase the throughput by, if you still want to increase on demand, you can add more servers to the cluster. When you want to do the planned maintenance, or software maintenance, you can eliminate the downtime because you can patch one server at a time. The other server can still be up, and you can eliminate unplanned downtime. Like one of the server crashes, then your database will still be up. So you can eliminate unplanned downtime. So these are the benefits of the cluster. Now, what are the high availability options in your Oracle database? Now, Oracle database high availability options when it comes to clustering can be SEHA, which is Standard Edition High Availability Feature, SEHA, sometimes called as SEHA, Oracle Restart, Oracle RAC one node, and Oracle RAC. So these are some of the options. We'll go through all of these options one by one. So what is Oracle Restart? So Oracle Restart is a feature, and I think I did not cover the SEHA. Yeah, I did cover. So Oracle Restart is the feature where you can have It is basically installed on a standalone server, and it is only for the single instance. And it allows to, for if it will allow the HA. So if something happens, the database, when you start the server, automatically if you have enabled the auto start, then HA will come up, and the database will come up. So you don't have to manually, if the server reboots on its own, the Oracle restart takes care of restarting your database, restarting your listener. You don't have to manually intervene. And it needs a standalone server. It does not need a cluster. It is basically on a single, so it needs the Oracle Grid infrastructure or Oracle cluster software for a standalone server. SEHA is the facility which allows you to enable the high availability, where at any point in time only database can run on particular node, the another node they will be down. So it is basically an active passive kind of solution in Oracle RAC. And what exactly is not, sometimes you call it as a RAC, but it's not a RAC, because it is basically an active passive solution. Your database can be active if, let's say, you have two node SEHA environment, and if your database is up on one node, then the other node it is passive, and for some reason you want to reboot the first node, then what you can do is you can relocate the database from one node to another node. So it will shut down on this node and it will be up on the second node. That is the active passive solution, and this particular solution is enabled for the standard edition. So you can implement this in the standard edition, which saves your licensing cost. This particular feature needs Oracle 19.7, so RU 19.7 or later, and it needs a grid infrastructure. So you have to install the grid as you are installing the RAC, and when you actually create the databases, that time you have to decide that you are going for a standard edition high availability. The next option is Oracle RAC one node. It is an active passive similar to RAC. However, the advantage of this is like before failing over your database to another node, you will first start the database on the second node and then you will relocate. So it minimizes the downtime. And this particular option supports rolling upgrades such as patch set, database and operating systems, and it needs Oracle Grid infrastructure same as SEHA. It needs the Oracle Grid infrastructure enabled. So this is another option for your high availability. The last option that we are going to cover here is the RAC, the most important Oracle RAC, and it is an active solution. It is an active solution. It enables multiple servers. So basically you can have the database is on the shared location. The database is on the shared location, and there are multiple instances or multiple database servers, and all of those database servers connect to the same database. So application will be connecting via, some applications will be connecting via server 1, some application will be connecting via server 2, or a cluster member 1, cluster member 2, or cluster node 1, cluster node 2. You can call anything. These are multiple servers, multiple instances, same database. They will be, when they update the transaction gets updated in the same database. So behind the scene, it's the same database. It needs the Oracle Grid infrastructure to be installed. It supports rolling upgrades, patch set, database and operating system, and it is an active solution. So basically these are the four types of options. SEHA is an active passive. Oracle Restart is for the standalone. Oracle one node is for the also active passive. However, advantage is like you can start the database on the other node before you fail over, and the RAC is an active solution. Now that we have understood the options for Oracle database, let's go ahead and understand the concept of Flex cluster. So basically the Flex cluster is nothing but, starting from Oracle 12.2, all clusters are configured as Oracle Flex cluster. Basically Flex cluster is nothing but a cluster which is configured with one or more hub nodes and can support larger number of nodes. Oracle Flex cluster consists of hub nodes and leaf nodes. So this is an ASM. Flex cluster comes into the ASM. So ASM, in the ASM world, what you have is like you have a hub node. So you have Oracle Flex cluster is consist of hub node and leaf node. So it is consist of hub node and leaf node. And hub nodes is actually the one which has got a direct access to shared storage, and that should be at least one hub node, and you can have maximum 64 hub nodes. Leaf nodes do not have direct access to the storage. Leaf nodes actually uses the hub nodes to access the storage. So leaf node access the data through hub nodes, and you can have many leaf nodes. Hub nodes can be 64, but you can have many leaf nodes. Now, what are the requirements for your clusterware? So you need to make sure that all the servers where you want to install the Oracle clusterware must use the same operating system. You can't have the mix and match. You can't have one Windows server and one Linux server. You can't have that. You have to make sure that they have same operating system and at the same level. Also, you need to make sure that the operating system is certified by the Oracle clusterware. So Oracle has certified that. Otherwise, you might be able to install it, but Oracle will not support it. So that is very important. The another thing is a cluster node needs a second network, which is called interconnect. This is very important, interconnect, or in other words, cluster member needs at least two NICs. So one for the interconnect and one for the public IP. So one for the public communication, where your host will communicate and you can log into those hosts, etc. So one will be the public IP and another one will be the private IP, which is also part of the interconnect. So and the interconnect is the private network and only cluster can access. You should make sure that you cannot connect to the interconnect directly. If you try to ping to the interconnect, you should not be able to ping to the interconnect, because only the cluster should be able to connect to the interconnect IP or the private network. And also one of the things, like you should install the Oracle cluster binaries on a local disk directly attached to the server. So you by default, when you install the operating system, there will be a disk where you will install the operating system. You can use the same disk or you can have another disk, but that disk should be local to the server. You should not use the you should not use the shared disk, because if you use the shared disk and if anything happens to the binaries, any issue happens to the binaries, the entire cluster will go down. So to prevent or support the HA availability, you should make sure that the binaries are installed on a local disk, which is internally attached to the server. Now, what are the storage consideration for Oracle RAC? So Oracle ASM is supported storage. There is another options, shared storage, etc., etc. I will not go into those details, but one of the supported storage is Oracle ASM. You can use the same disk group for database files, OCR and voting files, or you can use different disk groups. So OCR, voting disk, database files, and I'll cover what is OCR and voting disk. I'll cover them, but you can store the OCR, voting files and database files in the same disk group, or you can use the different disk group. Oracle recommends that you create at least two separate Oracle disk groups, one for the data file and one for the recovery. So recovery file is nothing but FRA, fast recovery area. So Oracle says that you should at least have one for the data file and one for the recovery file. Now, if you create only one disk group for the storage, then OCR and voting files and data files and recovery files are contained in one disk group. It is possible that you can have only one disk group and you can store absolutely everything. You can store OCR, voting files, data files, the FRA, recovery files, etc. in the same disk group. If you create multiple disk groups for storage, then you can separate this. You can have a separate file for OCR, separate for voting file, separate for data file, separate for recovery file. You can have something like that. No, basically what I would suggest is like keep OCR and voting file as one. The data file should be in a different disk and the FRA should be in the different. So at least have 3 ASM disk group, one for OCR and voting file, one for your database files, and one for your recovery files. That would be my recommendation. Now, this is an important note. Oracle clusterware is installed independently of Oracle database. So after you install Oracle clusterware, you can install Oracle database. So you have to install the clusterware software first, and then you have to install the database software. You cannot install the database software without installing the clusterware, and the database software is installed separately. So first you finish the clusterware installation, and then only you go for the database home installation or the database software installation. Now, what are the Oracle clusterware files? So Oracle clusterware files are basically, you can have OCR, OLR and voting files. So you can have OCR, which is Oracle cluster registry, OLR, which is Oracle local registry, and voting file is nothing but about the node membership. So the Oracle cluster registry is the configuration. So basically it stores the clusterware and database configuration information. So it stores everything, and I'll cover more into detail. OLR is local on every node, and voting file is basically about node membership, and it should be accessible by all nodes in the cluster. So let's take a look at all of this in detail. So what is OCR? OCR is the file which contains information about all Oracle resources in the cluster. It is used to store and manage information about components such as what are the RAC databases, what are the listeners, what are the virtual IPs, what are the services, etc. You can use OCR config, OCR dump, OCR check to manage OCR OLR. So you can use this utility to manage this OCR and OLR. Oracle recommends that you define multiple OCR locations. You can have up to 5 OCR locations. Each OCR location must reside on a shared storage that is accessible by all nodes. So make sure that every location that you are keeping the OCR, that should be accessible by all nodes in the cluster. You can replace a failed OCR location online if it is not the only OCR. So let's say you have configured 2 OCRs locations. If one of the OCR fails, then you can restore it, you can replace it without bringing down the cluster. You can do it online. However, if it is only single OCR, you cannot do it. So only if it is a redundant, if there are more than one OCR location, you can replace it. If there is only single OCR location, you cannot replace it online. You have to start the cluster in exclusive mode. You can store OCR and voting files on a Oracle ASM disk groups. So the OCR and voting files can be on the Oracle ASM disk groups, and if you are the backup of OCR and voting files, so that will be an automated backup that Oracle automatically takes of OCR and voting files. You can also take a manual backup, but the Oracle suggests that the backup of OCR and voting files should be on a different, there is no backup of voting files, there is only backup of OCR. The backup of OCR should be on a different disk group from the location, the disk group where you are storing the OCR file. So these are the Oracle recommendations. So this is about Oracle Cluster Registry. So Oracle Cluster Registry is a shared location and it should be accessible by all the nodes. Now there is something called OLR, which is a local registry. Local registry is located on each node in a cluster and contains information only specific to that particular node. So it does not contain the information about other node. It only contains the information about that node. That's why it is called a local, because it is local to that particular node. It contains manageable information about clusterware and dependencies between various services. HA services, Oracle HA services uses this information when it tries to start up the cluster or it tries to manage the cluster. So basically this is very important. If you have lost the OLR, then your cluster will not come up online. So you need to make sure you have the OLR. OLR is located on local storage on each node. So it is on each node, and OLR default location is grid based CRS data hostname OLR. So this is the default location of your OLR. And you have to replace this host name with the actual host name. So this is the grid base. So the location where grid home CRS data host name OLR. So this is the location of your OLR. Voting file. So voting file is the file which contains the information about node membership. So it is a information about node membership. It uses Oracle Clusterware uses voting files to determine which nodes are members of the cluster. You can configure voting files on Oracle ASM, or you can configure voting files on shared storage. Storage must be shared, or in other words, each voting file must be accessible. So you should make sure that each voting file is accessible by all nodes in the cluster. Very important. If any node that does not have access to absolute majority of voting files, more than half, then it is automatically restarted. So it will automatically restart on its own. You can dynamically add or replace voting files without stopping the cluster. So this is very important. You can dynamically add or replace voting files without stopping the cluster. Now, voting file recommendations. Oracle recommends that you have minimum of 3 voting files on a physically separate storage. You can have up to 15 voting files, but Oracle recommends not to use more than 5. 3 are recommended, and 3 are minimum, 5 are recommended. 15 supported, but you don't have to use all 15. Although 15 are supported, you don't have to. You can, maximum that you can go is 5. That is maximum. You can go up to 15, but 5 is more than enough for all the practical scenarios. Now, we will understand before we understand the IP configuration, I just wanted to show you the diagram. So the applications will connect to the something called scan. So, and you can have one or more scan IPs. So maximum is 3, and you can also have just a single scan. It is not that you have to have a 3 scan IPs. You can have a cluster with only 1 scan IP. That's also fine. Minimum you need to have, maximum you need to have 3, minimum you need to have 1. The scan IP should be in the same subnet as your public IP, and virtual IP. So the public IP, virtual IP, and the scan IP should be in the same subnet, and this should be the subnet where your applications are hosting. So this should be the same subnet. The private IP is the only IP which should be in a different subnet, which is for the cluster interconnect. So this is used for the cluster interconnect. All of these nodes should be able to access the shared storage. So they should be able to access the shared storage, and the applications can connect to the database using virtual IP, using public IP, or using scan IP, because they are only in the public subnet. However, if they use the public IP and if this server goes down, then the applications will not be able to connect unless you have something called, you have set up the application to failover. So to avoid configuring the failover at the application level, you can use the scan IP, which manages the failover. So if for some reason this particular node goes down, the scan IP will not redirect. Scan IP will know that this node is down, and it will not redirect any connection to this node. It will directly redirect to this node. So that is the advantage of scan IP, because you will be able to, you don't have to modify your connection or your application connection to multiple IPs. And even if you add the more nodes you can add, like you can add more nodes, you don't have to change the scan IP or change any configuration at the application. So application level changes are eliminated by using the scan IP. Now, so this is what I was talking about. So this I'm giving you an example of a 3-node cluster. So there are 3 nodes in the cluster, 1, 2, 3, and you can see that all of the IPs, the public IP, private virtual IP, and the scan IP, they are in the same subnet, 192.168.1. So this is the subnet of all of these IPs. Only the private IP is in the different subnet. Only the private IP is in the different subnet. You can clearly see from here. Okay, so the private IP is the only IP which should be in a different subnet. All others should be in the public subnet, and this should be the same subnet where your application servers reside. So the application should be able to communicate to your database using the public subnet. So the scan IP, public IP, virtual IP in the same subnet. Now, what is the virtual IP address? So virtual IP address is basically registered. It's a as you can say, it's a virtual IP. If the cluster is down, the VIPs are down. You will not be able to get any response from your virtual IP. End of the story. If you try to ping to virtual IP, you will not be able to ping to virtual IP if the cluster is down. It is basically, it is in the form of the virtual IP. You have to create a hostname.vip, and to this you will map the virtual IP. So you will create, and the virtual IP should be in the public subnet, and basically it allows the application to send the client request to the other node if the node is down. Okay. And so and that is the reason why it should be in the public subnet. So because it allows the client request send to the node if the node is down. So that is the reason why it should be in the subnet, because the VIP will allow the client reroute the connection to other node if one of the node is down, and the format of this is hostname.vip. The public IP address is again configured in the DHCP or DNS, or you can also configure it in a host file. The public IP address is used by the public interface. So here there will be a public interface and a private interface. So there will be 2 NICs. So public IP, you will configure the public IP to this NIC, stands for network interface card. So the NIC, you will configure 2 NICs. So at minimum you need 2 NICs. One for the public IP, one for the private IP. Now you can have multiple private IPs, so you can have multiple NICs, etc. We will cover that at a later point in time. So the public IP is where you set at a public network level, and this is should be in the public interface. So it should be in the public subnet. And basically public IP is the one using which you will be able to connect to the actual host. So if you want to connect to the actual host, you should be able to use the public IP or the public host name. The private IP is for the internode communication. It is also for the interconnect, and it is basically, you will configure this on a second NIC. And any interface that you identify must be on a subnet that connects to every node. So you need to make sure that whichever interface you define as a private, that particular NIC, subnet should be, there should be a NIC on every node, and that should have that same subnet. You cannot have mix and match of subnets. And the private interconnect is used for the cache fusion and other traffic nodes, and that is why it should be on a separate network. That is why it should be on a separate network. And remember that private IP address should be only reachable by the cluster nodes. You should not be able to ping to the private IP. You should not be able to ping to the private IP. That is very important. Now, note regarding private IP, this is what I was talking about. You can have multiple private IPs. So you can, here we are talking about only two interfaces. One interface for the public IP, one interface for the private IP. You can have multiple interfaces for the private IP. So you can increase the HA between the multiple interconnects. So you can have that. Now, but what you cannot do is, like, you cannot put the private IP in the same subnet as your public subnet. So you cannot do that. You cannot change your private sub IP to the subnet which you have configured as a public subnet. Oracle will not allow you to do that. What is scan? So scan basically is also another virtual IP, and you can have at least one address. It should have at least one address. Oracle recommends that you configure 3 for HA. You don't need more than 3. Even if you have 100 nodes in the cluster, you don't need more than 3. Maximum 3 is more than enough. It has been tested by Oracle that 3 will suffice. And basically it removes the need to perform manual service. So whenever your client tries to connect, because you are using the scan name, which is same, and even if you add node, remove nodes, the scan name will still be able to point to the correct nodes whichever are remaining. Whenever at the application level, you only need to connect using the scan name. You don't have to use the VIP. You don't have to use the public IP. You can use the public IP. You can use the VIP. However, scan is recommended because scan will be able to do your load balancing, and scan will allow to eliminate the changes at the client level. So application, it is recommended to use scan in the RAC environment. Minimum 1 address, maximum 3, more than enough. You don't, even if there are 100 nodes in the cluster, you don't need 100. So here I was talking about, here if for some reason you added a fourth node, so DB1, DB2, DB3, and now fourth node has come, DB4, node 4. You don't have to have 4 scan IPs. You still can keep 3. Minimum is 1, maximum is 3. That is more than enough. Now, remember that there are some parameters on the cluster that needs to be same. Instance number, they needs to be different. So instance number, has to be different. So you cannot have a same instance number or same if you are using the automatic undo management, then you should have the different undo table space. So there are some parameters in the RAC that needs to have different values per node. So you cannot have instance number is 1, the undo table space is another. You cannot have same values across the RAC cluster. However, there are some parameters which needs to have identical settings, such as compatible, cluster database, control files, block size, domain, files, DB name, file dashed, recovery file dashed, unique name, instance type, execution, remote login, password, undo management. These are all the parameters that needs to have the same settings across all of your clusters. So if somebody asks you what are the parameters that should have identical values across all the cluster, you can find out that these are the parameters that would need to have the same values across the cluster. These are some of the parameters that needs to have unique values across the cluster. The installation guides. So basically what I want to say here is, like, you can have different releases of clusterware, different release of Oracle ASM, and different release of Oracle database on the cluster. However, you should be aware of compatibility consideration. You can only have one installation of Oracle clusterware running in a cluster, and it must be installed in its own. So clusterware installation is in the grid home. So we call it as a grid home, and that is nothing but the location where your clusterware, and you can have only one installation. Now, release of Oracle clusterware that you must be using should be higher than ASM and the database. So you cannot have, Oracle clusterware 19c supports Oracle 19c database ASM 19c and Oracle 19c, and the databases, it can support the 19c database and 12.1. So if you have 19c clusterware, you can have one grid home which supports the 19c ASM, and it can support multiple databases. So but you cannot have Oracle 12c clusterware supporting Oracle 19c databases. So if you want to have Oracle 19c databases, then you need to upgrade. If you are running the Oracle 12c cluster, you need to upgrade your cluster. Higher level cluster can support lower level databases, not the other way around. So this is something that you need to be aware. Now, the upgrading and patching of Oracle clusterware. So this is so Oracle clusterware supports in-place patching, and it supports out of place upgrades, etc. So in place means you are actually upgrading the same software in the on the same location. So basically, if the grid home is installed and in a particular directory, and you are replacing that in the same binary location, then that is something called in place. Out of place means you are actually going to install another home and then you are going to update. So that is an out of place. Oracle also allows you and remember that clusterware supports clusterware supports in place and out of place. However, the database only supports out of place. You cannot upgrade the Oracle home. The rolling upgrade, there is another thing called rolling upgrade, where you actually can, what you can do, you can upgrade one node at a time. So you don't have to upgrade all the nodes, and you can upgrade one node at a time. So the other node can still be up, and the applications can still connect to the other node. And once you have completed the first one node, then you can fail over the databases, start the node, and you can do the upgrade so that is something called rolling upgrade. So you can do the rolling upgrade. And Oracle also supports the force upgrade in case where some nodes of the cluster are down. So that is something that to be known. Now, the Oracle clusterware components. So the Oracle clusterware is divided into two separate technology stacks. One is called CRS stack and one is called HA stack. So the upper stack is CRS stack, the lower stack is HA stack, and there are multiple processes which actually facilitate the CRS stack and HA stack. So there are multiple processes and we will look into that. So the CRS stack is made of cluster ready services which are responsible for managing the high availability in the cluster. CSS, which is cluster synchronization services, by controlling which nodes are members of the cluster. ASM, to provide the disk management. CTSS, cluster time synchronization services for the time management. Event management for event publishing. Grid naming services for handling the requests sent by external DNS servers and performing the name resolution. So grid naming service. Oracle agent, the support Oracle specific requirements and complex. So this is one of the main process. ONS for publishing and subscribing to fan events. Basically there is no dot here for fan events. And Aura root agent, a specialized Aura agent to manage the CRDs, the resources, to manage the resources such as network, grid, VIP, etc. etc. Now remember one thing. The Aura agent and Aura root agent will be there in CRS stack, and it will be also there in the HA stack. So here you can see Aura agent and Aura root agent. So you can see this Aura root agent and Aura agent and Aura root agent is different from this. This Aura root agent and Aura agent and Aura root agent is different. This Aura agent and Aura root agent is different. This is part of the HA stack. This is part of the grid stack, the CRS stack. So what are the processes in HA stack? So logger ID, so to log the information from all nodes. The inter-process communication, which allows to do the interconnect usage. Grid plug and play, so coordinates it accesses the plug and play profile and coordinates updates to the profile. Multicast domain name services, so which used by grid plug and play to locate profiles, etc., and to perform the name resolution. The Oracle agent, so this is to manage the daemons such as clusterware owner, GIPC, GPNPD, etc. This is for the managing the CRSD, help CRSD to manage the CSM processes and system monitor services for monitoring and operating metric collection, etc. There are other processes that I have not covered. There are other processes that I have not covered. I have just covered the main important processes. So basically I have covered all the topics. So what kind of what kind of interview questions? So if you ask what are the benefits of cluster, you can explain that. What are the different types of high HA availability options in Oracle database in the clusterware environment? This is not, there are data guard, that is golden gate, etc. But what are the options in the clusterware? So you have standard edition, high availability, you have Oracle Restart, you have one node, you have RAC. What is Oracle Restart? Covered that. What is Seha? Covered that. What is one node? Covered that. What is Oracle RAC? Covered that. What is a flex cluster? Covered that. What is the leaf node? What is hub node? Covered that. What are the system requirements for clusterware? Covered that. What are the storage considerations for Oracle RAC? Covered that. What is how, when you have to install the database, when you have to install the clusterware? Covered that. What are the Oracle clusterware files? OCR, OLR, voting files? Covered that. What is OCR in detail? What is OLR in detail? What is voting file in detail? What is the recommendation for voting file? What are the interfaces for your cluster? What is the where the public IP, where the virtual IP, where the scan IP, which subnet they should belong, where the private IP, which subnet they should belong. What is the concept of virtual IP? What is the public IP? What is the private IP? What is the how many interconnects you can have? What is the scan concept? What are the parameters that have unique settings? What are the parameters that should have same settings across all the instances? What are the installation guidelines? You can have higher level clusterware. How the patching is done? What are the clusterware components, the CRS and HA services, and what are the different processes? So we have covered all of this in this particular tutorial. I hope this particular tutorial was useful. I hope after watching this particular video, you will be able to answer the Oracle RAC questions. There is another video that will come and that will talk about Oracle commands. So we will go through a lot of Oracle commands which will help you to manage your cluster. I hope this particular tutorial was useful. I hope you learned something new today. Thank you for watching. See you in next tutorial. Till then, bye bye and have a nice day. Thank you. Bye.